I'm here to talk about a shell that shouts at you. A disclaimer, I'm not going to shout here on stage. This is also talk about how I learned a little bit more about Linux and files and terminals. And it's also how a tweet got me into writing lots of Rust code for no particular reason. So 2 years ago, a very good friend of mine, Florian, also known as Agarak, tweeted a single word, standard shout. And someone else named Pobox replied, well, now I kind of want a magic FD that assumes UTF-8 and upcases everything and appends bang, 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 one bang to it. So when I read that, I thought, well, what if we actually do this for every single program that you launch from your shell? How would that work? What do I need to do to make this actually work? Well, if you ever used Linux or shell, you probably heard that everything is a file. Now, it turns out everything is actually identified by a file descriptor. And actually, a file descriptor is just a number. Now, just to add to the confusion, the Linux kernel actually has file descriptions internally. That is not totally relevant to our talk, though. We're going to stick to file descriptors. Now, even if you've never really used file descriptors directly, because you probably worked with a higher level language which doesn't expose that directly, you probably still have interacted with file descriptors in some way or another. Because there are always three of those. There's standard in, which is the input. It's usually your keyboard of your laptop or your machine, where you type stuff and your application receives this input. There's standard out, which is usually simply connected to your output, your terminal, or your stream. And then there's standard error, which is also connected to your output, your terminal, with small differences, but we don't care about those today. Now, before I said these are just numbers, and the same is true for the standard file descriptors. Standard in is just 0, standard out is 1, and standard error is 2. And now it turns out none of these are any special. They act and behave just the same as every other file descriptor you will get when you open a file. That also means we can just execute the same functions on it. For example, we can close standard out. Now, what happens if we try to print something? Well, nothing. We don't see anything anymore. We close standard out. We can't print to it anymore. So now let's open a new file. We call it file.txt. And yes, this is a low-level POSIX API to open a file, for example, in C. And this returns us a file descriptor. We assign that to FD. Now, what is this FD? Well, before I said it's a number. But can you guess which number it is? Well, it's 1. Linux is pretty simple in this regard. It just picks the lowest unused number. And for us, this is simply 1. Because remember, we previously closed what used to be file descriptor 1. So what happens if we print again? Well, we still see nothing. Because we actually modified what is file descriptor 1 and put just writes to this file descriptor 1. So our text that we printed actually just ends up to be in our file now. We controlled what file descriptor 1 is. But now for something completely different. To affect every program's output, we somehow need to run before it to set something up. But how do we do this? How do we run something before everything else without them noticing it? Well, it turns out on Linux there's a special environment variable which lets you load arbitrary libraries which get loaded and run before any other library. Before your standard library, before libc, before your program. Now what can you do with LD preload? Well, you can do a lot of stuff. You could do time travel by modifying time functions. You could change pretty much anything about the environment, and the application that will run after will see the changed environment. You could pretend that you're running on an X4 file system so that Dropbox still works, even in the newest version, even if you don't run on X4. And you could disable TLS cert validation, but please don't do this. But it's also code, so you could do pretty much everything else as well. But LD preload only loads libraries, and libraries don't really have a main function, so how do we actually run code before anything else? Well, there's a solution for that as well. there's a not well-known attribute to create a constructor in your code. In GCC, this is just not marked by this part. And if you put this on a function, the compiler puts it in a special place in your final library, and this function then is executed before any main function. That includes the main function of the application that we run after. So this now allows us to actually run code. But now for something completely different. Remember standard shout, bang, 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 one bang. That was the original request, and we haven't written that yet. So what do we want to do? We want to take every input, uppercase it, and append bang, 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 one bang. Now I'm a Rust developer, and it turns out this is a pretty easy task in Rust. To turn something into all uppercase, you literally just simply call to uppercase in a string. To append bang, 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 one bang, you can simply use the add operation, and it will just work. Now we can turn this into a function, which takes some input, uppercases it, appends our bang, 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 one bang, and returns a new string. Finally, we read something from standard input, shout it out, write it to standard output, and we're done. And it turns out this works. We can standard shout now. But we're not running before everything else yet. So how do we do this? Well, I mentioned it before. We can use LD preload for that. And obviously, attribute constructor. So we can now combine this to run our standard shout just before our program and then do some more stuff. So let's write a constructor function. So we mark it with the constructor attribute, slightly different syntax here. And then we start shouting. But this middle part, what do we actually do there? We saw the shouting part, but we still need to handle the input from, or the output from our application. So how do we do something for every output that we get from some other application? Well, we also learned about that before. We can use some file descriptor magic. We can close and reopen and redirect these file descriptors as needed. And standard out of our application is just a standard file descriptor, so we can replace that. So the normal way your application would run, it gets some standard input, it does something, it writes something to standard out, and that gets displayed on your screen. Now, with LD preload, we actually run something just before, and in our library, we have the same environment as our application will get. That means we already know what the standard out is. And we also know what the standard in is, and we also can launch other applications. So what we do is take the old standard out, make the old standard out, store that away, make the standard out of the application the standard input of standard shout, and make the standard out of standard shout the actual standard out. This is essentially just a pipe, as you would use in your shell. And yes, you can totally achieve this in an easier way, but you would have learned nothing. So now that we have a library which starts some code, we can actually load this library and run our shell. And there it works. We shout everything that gets output, we shout onto the screen. And well, when I say every program, I really mean every program. And yes, that also applies to Git. Now the nice thing about having not only the library but also the application is that we can use the output of standard shout as the input for other stuff. For example, to make your commits much more on point. So this is how a tweet with just a single word led me down a path of understanding file descriptors and terminals and files. And so whenever you come across a silly idea, maybe just sit down and implement it. You might actually learn something. Quick shout out, I'm one of the organizers of a Rust Fest. It's going to happen this year in Rust Fest Barcelona, and if you want to learn more about Rust, this would be the place to come to. Thank you.